strikingly, I think it's a little hard to see this, was the unlikely event showed very little effect of queuing, so this is valid and this is invalid. But the likely event showed the dramatic effect that you expect to find. So in the previous paper, when I found this result, I just called it spotlight failure, as if when you put your beam of attention at a location in space, it only helped you with the things you were expecting to happen. Or you're already expecting something to happen at that location, but it only helped with the thing you were expecting to see, not the thing you weren't expecting to see. Called it spotlight failure. Importantly, if you use peripheral cues, the pattern becomes additive. This is just another demonstration from another study. You've got even smaller effect of, with endogenous cueing. So I replicated all of those effects in this study published actually the same year as Klein and Ponefract. But if we put the Brienne result together with this finding with non-spatial expectancy, so something that's not about space, it's about the identity of the target that's going to be presented. We have essentially a double dissociation. I'm using X to represent interaction and plus to represent additivity in the reaction time patterns. And as you might recall from Sternberg, X implies overlap in stages of processing, and additivity implies no overlap. So this is a double dissociation. It really tells us that endogenous and exogenous orienting are kind of dramatically different. In the 1994 paper, I said, it's intriguing to consider that the anterior and posterior attention systems, which have been distinguished on the basis of cognitive neuroscience evidence, may underlie respectively these two forms of orienting. Now, those are dissociations that were generated in my lab, but in the Klein 2009 paper, I show that there are quite a few other dissociations. I'm going to pretty much just enumerate them here. So these are the two we've just talked about. In the study that launched premotor theory, Rizzolatti et al. 1987, they actually based premotor theory on the results they got when they did a cueing experiment where targets could cross or not cross either the vertical or the horizontal meridian. I'm illustrating the Meridian Effect here, but it's not actually from their experiment. And what we mean by that is, suppose the cue is here at this location in a 4-location experiment positioned like this. So the target could occur anywhere. The cue occurs here. These two target locations are, at least in space, equidistant from the cued location. And what Rizzolatti et al. Demonstrated and other people have confirmed is that the cost when the target occurs at an uncued location that's equidistant from the cued location, these two, the cost is greater if attention has to cross a meridian. So the cost here would be significantly greater than the cost here. I'm not going to go into why they thought that was support for premotor theory, because I don't think it was particularly good support for it, but the finding is robust. But it only occurs with endogenous orienting. It doesn't occur with exogenous orienting. So that's a dissociation. Another interesting one comes from patients with parietal damage who are suffering from either neglect or extinction. And this is something Posner demonstrated in a 1980s paper in which he hypothesized that individuals with neglect and or parietal damage suffered from a difficulty disengaging from stimuli, cues, that were presented to the good visual field in order to attend the bad visual field, and that was what was responsible partly for their neglect. So in a Posner cueing paradigm, the disengaged deficit in neglect patients is shown by this incredibly bigger cueing effect for contralesional targets. And in a review paper that I published with my graduate student, Bruno Lozier, we showed that disengaged deficit is present as long as the cue is peripheral. And what we've shown here is the pure case where the cue is peripheral and has no meaning. We call it conflated case where the cue is peripheral but means something. And it's very much, it's not absent, by the way, but it's very much smaller if you only use endogenous or central arrow cues. So I consider that another dissociation. The disengaged deficit is robust with exogenous cueing, but it's small with endogenous cueing. There's this interesting phenomenon called illusory line motion. Just look at the screen. I'm going to present a line. So most people perceive that line as being across the screen, drawn across the screen from right to left. We can do it again. But if you looked at the PowerPoint, or it's actually a keynote presentation, you would see that it's just presented all at once. And some people, when this phenomenon was discovered, proposed that it was about attention. Not just that there was a stimulus on the screen, but that your attention was focused on it. So with John Christie, I decided to find out whether illusory line motion, is what we call this phenomenon, is generated by endogenous or exogenous attention, or by both. And what we found was, no, you need a cue you need the stimulus in the periphery. If you don't have a stimulus in the periphery, you don't get illusory line motion. Finally, because we're going to have a whole class on inhibition of return next week, I'm not going to tell you much about it, but it's well known that inhibition of return is generated by a peripheral event, and that attending in the periphery endogenously and then canceling that attention, returning to neutral, is not followed by inhibition of return. So we have all of these different dissociations, and therefore I've concluded that there's two different beams. There's two different controllers, the endogenous controller and the exogenous controller. One is reflexive, one is more voluntary. But when they're controlling attention, they're really controlling different resources because they have different effects on the processing that happens after. And I think while this may not have been a widely held view in the 80s and early 90s, I think most people have come over to this view now. This is just a reminder that in Broadbent's model, the concept of filtering and limited capacity were important. I don't know, over 2 decades ago, I wrote a book review of Bestrit for Broadbent. And I predicted in that book review that whereas researchers had been extremely interested in selection, specifically because Broadbent plays such a big role on it in his model, that in the next generation they were going to be much more interested in control. This is a Web of Science retrieval of all the articles that have either cognitive control or executive control in the title of the paper, published between 1994, which is on the far right, and today. Well, not quite today because I didn't include 2019, but recent times on the left. And you can see that, yes, we've become very preoccupied by the concept of control. And it's important when you're interested in a concept like this to know what terms people use to describe it. So executive control is one that I think Posner popularized in his attention network test. It's also called cognitive control or resource allocation or supervisory attention or executive function. And there's probably other words. And it turns out it's not quite a concise concept. It's really more like attention. So Posner had 3 networks of attention, one of which was executive control, and really executive control also is a rubric, or a phrase that refers to a lot of different things that are maybe all related, but they're a bit separable. Here's one definition from Cohn, Braver, and O'Reilly. By control, we mean the ability of the cognitive system to flexibly adapt its behavior to the demands of particular tasks, favoring the processing of task-relevant information over other sources of competing information, and mediating task-relevant behavior over habitual or otherwise prepotent responses. And I should mention that's only one definition, but it's a pretty good definition that captures a lot of what we're going to talk about. The famous Stroop Effect is widely used as both an example of executive control and as a test to measure our ability to do it. So the task could be to read the words, which is relatively easy, or to name the ink colors, which, because reading is so automatic, is relatively hard. So when Cohn and Braver et al. Were talking about prepotent responses, what they kind of meant was reading the words is a prepotent response for adults. If you have a 5-year-old, they won't have any Stroop Effect. They'll have trouble reading the words because they're only just learning to read. So for them, the prepotent response might be naming the ink colors, which they would probably be pretty good at. In the history of cognitive psychology, these are, for me, 2 very important papers on control, and you can see they're published considerably in advance of 1994, when there were still very few papers that had control or executive function in the title. Posner and Snyder, of course, I was very influenced by because I was a student with Posner up until '74, and most of this was written before then. We seem to not be plugged in. So I'm plugged in here, but we're not getting power, and I can see my computer is going to die. Yes, that's better. Thank you. And around the same time, Badley and Hitch published their famous and very influential paper on working memory. And these were 2 seminal papers. Posner and Snyder distinguished, they actually identified criteria for automaticity and had very cool methods for exploring when conscious control was playing a role. And Badley and Hitch proposed something along the lines of a central executive that had 2 slave systems with sort of different modes of or domains of processing, one about auditory and one about visual information. In the remainder of today's class, we're not going to talk about Badley and Hitch. I'm not sure if we'll return to it in this class. But we are going to talk about a particular kind of control. And this is coming to the Falk, Remington, and Johnston paper you could have read, but you may not have, but I'll go over it slowly. But importantly, you performed an experiment quite like their experiment 3. This paper created a huge amount of interest in the concepts that are embedded in their title: contingent capture and attentional control settings. And you can see attentional control settings is giving us some sort of emphasis on control. And I think this paper launched a huge excitement and many studies, because not everybody agreed with what they were saying, and yet they were saying something fundamentally important. So I'm going to tell us about their experiment 1 and their experiment 2 methods, but then I'm going to switch to experiment 3 without telling you about the results from those experiments, because experiment 3 combines the methods of experiments 1 and 2 and is a better experiment. So this is a sequence of events that happen on a trial, the participants looking at the middle of 5 boxes. Then there's a cue that's presented. It's 4 dots that surround one of the peripheral boxes. Then there's an interval, but it's a short interval. And then a target is presented. In different participants or different blocks of trials, the target is just a stimulus that appears in one of the 4 boxes, or the target is a singleton that's identified by a unique color. So 4 things appear, one of them is red, or just one thing appears and it's the target. And this is, the participant has to decide the identity of the unique item. We'll see what that looks like. You're fixating the middle, there's a cue, sometime later there's a target. In this case, a single onset item. Or there's a cue, and sometimes later there's an array of items, one of which is a singleton that's your target. So that was experiment 1. The cue was an onset, and in different blocks of trials, or different participants were exposed to the different kinds of targets. In experiment 2, the cue, all the boxes are, we could say, cued, but one of them is cued with a unique color. And the target is, as before, it's either a unique onset or it's a singleton color. So we'll see what that looks like. Oh, you're looking at the middle. The array appears of cues. One of them is red. Sometime later, an onset target appears. You have to decide if it's an X or an equal sign. Or the cue appears, and sometime later, an array of items appears, and you have to decide if the red thing is an X or an equal sign. I think importantly, in experiment 3, which was like the lab that you ran, the cues are, the different types of cues are mixed together, but the type of target is blocked. So the type of target, keep in mind, if your task is to make a decision about the target, your, what they call, attentional control setting is going to be geared towards finding the target so that you can make the decision that you have to make about it. And think about it, the cue is actually not relevant to your behavior. It's not even informative about where anything is going to occur. So your attentional control setting, it's a little bit like what Cohn and Braver said. It's how are you going to organize your system for doing the task. The cue is not relevant to the task. Finding the target is relevant to the task because you have to decide if it's an X or an equal sign. So they mix the cues, but in one block of trials, the target is an onset, and in another block of trials, the target is a color singleton. The results, I don't know what the results were like from our lab, but the results are pretty dramatic and important. Let's look at the onset target results on the left-hand side. So the target is a unique onset. We're looking at whether the target was presented at the location where the cue had been presented. Remember, we call that valid, or where the location where the cue hadn't been presented. There would be 3 of those, invalid. And what we see is when the target is an onset, the onset cue has a cueing effect. But the color cue has none. So you could say attention was captured by the onset cue, and therefore hurt performance on invalid trials, and possibly help performance on valid trials, but it doesn't look like it helps. In contrast, the singleton unique color cue has no effect on performance, whether your target is at the location of that color cue or not. And the accuracies don't contradict anything we just said. If instead we look at the color target data, now the onset cue is having no effect. That's the black line connecting 2 circles. So the onset cue that captured your attention when you were looking for onsets has no effect when you're looking for the singleton red thing so that you could decide if it was an X or an equals. But the singleton red cue now matters robustly. It produces very big costs when the target is not presented at that location. So as I've said, this paper generated excitement about these 2 related concepts, attentional control settings and contingent capture, and probably hundreds of experiments have been done since this paper was published in 1992 to explore what's going on here.